Welcome to Study Loop.
Let's look at this chemistry problem about pressures and when the stopcocks are opened and all of that. But before I work on this problem, I recommend students to pause the video, do the questions themselves, and come back to see if they got it right or not. That is a true way of knowing if you fully understand the topic. So hopefully you've paused the video and done the question. Now let's work on it together. So in this situation, we want to calculate the vapor pressure after the stopcocks on the burettes are open, right? And we should look at the information that we have. So we have the volume after which is 3 liters, right? So let's start with N2 nitrogen, right? The useful information or the useful formula in this case would be this, right? P1 V1 equals P2 V2 because we have the pressure and the volume. So we have, and we want to figure out P2, right? Because it's the after pressure, we already have the initial pressure. So work on this. We have 1 atm times V1 equals we already have V1 actually. We have V1 since the question stated that there are 3 1-liter flasks. So V1 in this case would be 1 liter, and we're left with P2, which we want to find out, times V2, since we know that the volume after the stopcocks are open is 3 liters, so it would be 3 liters, and we can obviously rearrange to make P2 the subject. So it would be 1 divided by 3, right? Which is do 1 times 1 and divide that by 3. So P2 should be for nitrogen. Now that we've worked on nitrogen, I think it would be, we can move on to water. So for water, we were given the pressure, which was 42 at, and obviously this unit here is very useless to us. We would want to convert it into ATM, right? So what is the conversion for that? It is 1 ATM is equal to 760. Right? So if we want to figure out the pressure of H2O in atmospheric pressure, we need to do 1 atm times and divide that by 760 being the unit conversion here, right? As you can see, and this would give us the pressure of water as 0.0553 atmospheric pressure. And we are given the mass of water, right, which is 2 grams. So think of the formula that would be the most suitable in the situation. Yep, it is N equals PV divided by nRT. So this formula here, right? N equals PV. And we know the pressure. We want to figure out the mole, right? So we know the pressure, M equals and we can times that by 3 liters, since that is the volume after the stopcock is opened. And we know R is like a constant, which is 0.082. Right. This is the unit for the constant. And we know the temperature, they've given it to us. Right. And I used my calculator and I got 0.00656 moles of water. And now that we have the moles, we can figure out the mass of water, right? So the formula for that is mass equals mole times mR, and you can easily find the mR from the periodic table. So in this case, it would be 0.00656 mole times about 18 grams per mole. And that should give us the mass of 118 grams using a calculator, which an interesting observation to make is that this mass is lower than the mass of water in the flask. Finally, we can move on to ethanol. It's written like this in the question, but I feel like the proper way to write it is the way that I wrote in black here. Okay. So let's start with what we're given. We're given the pressure of ethanol, which is right, and obviously we need to convert this into atmospheric pressure. So if you remember the conversion rate, you can do it. And that should give you 0.13421 atmospheric pressure of ethanol. And we have the mass of ethanol, which is 0.5 in this case. We must check if more than 0.5 of ethanol has evaporated. And of course, the best formula to use is we want to figure out the moles, right? Zero point 0.082 you already know is the constant. And temperature, I'm using the calculator, I calculated that to be moles. And you can use the moles and MR to figure out the mass, right? And in this case, I got moles times the MR, which you can easily find in the periodic table, and I got calculated that to be 46.07. When you times that together using your calculator, you should get this as your mass of ethanol, which interestingly enough is more than the amount in the flask, because ethanol was 0.5, but then after it is more than the amount of the flask. So the pressure should be less than 0.13421, right? Pressure that we calculated before, 0.13421, the pressure should be less than that, since we can see that the mass has increased of ethanol. If you've reached this far, you probably realize that we're still not done with the question, right? We have to do we have to figure out the total pressure. We still haven't really figured that out. Using my calculator, I get that. Right. And now we actually want pressure, so we can rearrange the PV equals nRT equation to get P equals, right, so that should be and I'll divide that by the volume, which we know is 3 liters after the stopcock is opened, and that should give me pressure to be, using a calculator, 0.0914. Right. But we're still not done because we have to calculate the total pressure, so we have to add the pressure of nitrogen, water, and ethanol all together. So we can do that here. We know that the pressure for nitrogen that we calculated before is 1/3. So this was the pressure for, and then we add it with the pressure of H2O, which was 0.053. Yes, we calculated it to be that. And then finally the pressure of ethanol, which we got as 0. And that should give us about 0.4 atm. So that was the final answer, and I hope that was helpful.